So now we are going to see the tracking of radars. So what is the main parameters of tracking radars is range, frequency drift, azimuth and elevation angle. So these tracking radars are used for finding the distance, velocity and direction of the object. So for this we are going to use FC radar servo tracking system. So here motor, physically rotate antenna, electro heterodyne motor for large systems, electric motors for small systems. So servo mechanisms, the control direction of antenna rotation, receive two inputs tracking azimuth at a point at and antenna position sensor. So servo mechanism servo mechanism is used to control the antenna for the required directions. Introduction. A tracking radar system measures the coordinates of a target and provides the data which may be used to determine the target path and to predict its future position. All or other part of available radar data range. The continuous tracking radar supplies continuous tracking data and particular target. The track while scan supplies sample data on one or more targets. In general, the continuous tracking radars and the TWS radars employs different types of equipment. So the antenna commonly employed with tracking radar is symmetrically pencil beam, in which the elevation and azimuth beams are approximately equal. However, a small pencil beam antenna is not suitable for tracking radars unless means are provided for determining the magnitude and direction of the target's angular position with respect to the same reference directions, usually the axis of the antenna. So now what is the difference between the target position and the reference direction in the angular error? The tracking radar attempts to position the antenna in make an angular error is 0. When the angular error is 0, the target is located along the reference direction. So the various methods for generating the error signals are classified as sequential lobing, conical scan, simulation lobing or monopulse. First we are going to see about the sequential lobing. So one of the method obtaining the direction and the magnitude of the angular error in the one coordinate by alternating switching the antenna beam between the two positions. This is called lobe switching, sequential switching or sequential lobing. A single beam is switched between two sequent angular positions to obtain the angular measurement. See here. This is the first block. First diagram shows the lobe switching antenna pattern and error signal, one dimension. Second one is polar representation of switched antenna pattern, and third one is rectangular switch. So one signal, beam, that is one beam is rotating from certain angle to angle. So if any target is present there, then it acquires the target information and it gives to the radar. So next, the difference in amplitude between the voltage obtained in the two switched positions is a measure of the angular displacement of the target from the switching axis. The sign of the difference determines the direction of the antenna must be moved in order to align the switching axis with the direction of the target. When the voltage is in the two switched positions are equal, the target is in on switch axis and its position may be determined from the axis of direction. Two additional switching positions are needed to obtain the angular error in the orthogonal coordinates. Thus, a two-dimensional sequential lobing radar might consist of cluster of 4 feed-horn illumination, single antenna, arranged so that right, left, up, down sectors are covered by the successive antenna positions. Both transmissions and receptions are accomplished at each position. A cluster of 5 feed might also be employed, with the central feed used for the transmission while the outer 4 feeds are used for the receiving. So next we are going to see the conical scan. Conical scan, a rotate continuously an offset antenna beam rather than discontinuously step the beam between four distinct positions is known as conical scan. So here this is the conical scan beam, how the beam axis is rotating in the squilt angle. Beam axis is rotating in the squilt angle. So here rotating, we are having the beam axis, rotation axis, beam rotation, target axis and squint angle. Or nothing but squint angle is nothing but the predetermined angle that can be shifted by the known angle. So this is the radar, this is the antenna beam we are going to generate it, that beam we are going to be such. Due to this, what is going to be happen is we are covering the large area to find the target. So the angle between the axis of rotation and the axis of antenna beam is called squilt angle. So the echo signal which will be modulated at a frequency equal to the rotation frequency of the beam. So the amplitude of the echo signal modulation will depend upon the shape of the antenna pattern, the squilt angle, the angle between the target line of the sight and the rotation axis. The phase of the modulation depends on the angle between the target and the rotation axis. The conical scan modulation is extracted from the echo signal and applied to the servo control system which continuously positioning the antenna on the target. When the antenna is on target, the line of sight to the target and the rotation axis coincidence and the conical scan modulation will be 0. So this is the basic block diagram of the conical scan method. So here we are having the duplexer, receiver with AJC and second detector, range gate, and we are having two motors. One is the elevation servo motor, other one is the azimuth servo motor. So here like when the signals are coming here, elevation angle, the error detector is detected, we are sending the error signal. So we are automatically it is adjusting the rotor of the antenna. So this is the reference generator. So the rotor joint on antenna is adjustable to the required directions. So this is the block diagram of conical scan tracking radar. So the antenna is mounted so that it can be positioned in both azimuth and elevation by separate motor, which might be either electric or hydraulical driven. So the antenna beam is offset by tilt either the feed or the reflector with respect to one another. One of the simplest conical scan antenna is a parabole with their offset rear fed rotated about the axis of the reflector. If the fed maintains the plane of the polarization fixed as it rotates is called knotting feed. The rotation feed causes the polarization to the rotate. The latter type of feed requires a rotatory joint. The knotting feed requires a flexible joint. A typical conical scan rotation speed might be 30 rpm revolutions per second. The same motor that provides the conical scan rotation of the antenna beam also drives two-phase reference generator with two outputs 90 degrees apart of the phase. These two outputs serves as the reference to extract the elevation and azimuth angle. The received echo signal is fed to the receiver from the antenna by two rotary joints. One rotary joint permits motion in azimuth, the other in elevation. The error signal is compared with the elevation and azimuth reference signal in the angle error detectors, which are phase sensitive detectors. The phase sensitive detectors is a non-linear device in which the input signal is mixed with the reference signal. The input and the reference signals are the same frequency. The output DC voltage reverse polarity has the phase of the input signal and charges through 180 degrees. The magnitude of the DC component from the angular error detector is proportional to the error in the signs, and the angular error detection output and amplified the driver, the antenna elevation and azimuth of servo motor. The angular position of the target may be determined from the elevation and azimuth of the antenna axis. The position can be read out by means of standard angle transducers such as synchronous potentiometers or analog to digital data converters. So next one we are going to see the AGCs. So this is the simple structure of ADCs. And disadvantage of conical and in-tray, the require of the minimum number of pulses to extract the angular error signal. So this tracking accuracy will be degraded by the fluctuation target cross section. The fluctuations echo can severely limit the accuracy. This disadvantage can be overcome by the monopulse tracking radar.